Hi everyone, and thank you for joining us for today's webinar, Amplify Predictive Analytics with Data Visualization. I'm Haley Mierswa with RapidMiner, and I'll be your moderator for today's session. I'm joined today by Founder and CTO of RapidMiner, Dr. Ingo Mierswa. Welcome, Ingo.
Hey, good morning, everybody. Thanks, Haley, for the introduction. Today is really a topic I am very interested in. This is, I think, one of the three key problems we as data scientists often encounter. The other two are really about ease of use and the skills gap around data science. We always, of course, have data quality problems, but the third problem really is about how can we actually get the greatness we are creating, all the goodness of the models, into the hand of more people. How can we actually make sure that all the good patterns we find are also exploited and used for improving our business? So this is really what this webinar today is about, the amplification of all our results with the help of data visualization. Before we talk about how we can do this, I actually would like to motivate the problem a little bit better. And in order to do so, I would like to introduce a new character to you, a data scientist, and his name is Joe. All right, so let's have a look into the story of Joe. Joe is a data scientist. So we will see what Joe is doing every single day, but I hope you can actually relate to this a little bit at least. So many of the people here in the webinar today will probably see similar problems like Joe here. All right, so Joe is sitting, like we all do, in front of his computer, working with programs like RapidMiner, and sifts through all the huge amounts of data Joe has accessible to him. So he can really look for new patterns, try to optimize the business by figuring out, okay, how can we really do the right things? That is Joe's daily job, and he's doing this every single day. Of course, not always he's finding good stuff, but hey, let's say 6 months later, Joe finally found a churn pattern in the data. Let's say you have some churn problem and you're looking for who are the people who are shifting over to competitor, for example, or stopping a contract. So you found some pattern you can believe you can actually exploit this pattern. Well, in Joe's world, this is really a pot of gold. So that's not a potato, it's a pot of gold. I just want to make sure that people not think my drawing skills are that bad. So this pot of gold is important for Joe, and not just for Joe, also for his fellow data scientist colleagues, Fred and Peter. So Fred and Peter are totally excited. They congratulate Joe. He gets the first prize as the best data scientist ever. The three of them are celebrating the whole night. Everybody's happy. But about a week later, something happened. A week later, Joe suddenly became very sad. So why is that? And that's a typical pattern I, as a data scientist, see among the other data scientists. You're first totally excited about the results, but then a little bit later, you would like to take the results and transform your business, but you figure out actually nobody else really cares. It's only Fred and Peter, your fellow data scientist colleagues, who really like what you did, but everybody else, not so much. So why is that? In many cases, Joe's models are not used or not even recognized, or the goodness is not recognized, because those predictive models, they tend to be really hard to understand. All those formula, all the mathematics, strange patterns, which really take some time to understand fully. That's why also, unfortunately, poor Joe, Fred, and Peter often sit somewhere in the basement. They're not really, well, other people do not really recognize the great value they're creating because they simply do not understand the great value. And this disconnect, of course, is a problem, but Joe thought about, okay, what can I do to amplify my voice? What can I do actually now to take this great pot of gold I found and give this into the hands of more people so that actually our business can improve? Okay? I hope you can relate to the small story of Joe, the data scientist, because I certainly can. I'm in this field for 15 years now, and I've been running into this problem over and over and over again. I found a great model with the potential to change the business, but unfortunately, I didn't really manage very well to get this model into production use. Well, often I did, but not always. So how can I do this in a way that actually this works much better? How can I really, well, improve the number of times or increase the number of times my models are actually used? And in general, I would like to present a framework to you, and this framework we call the operationalization of models. Because think about this. if you created a predictive model, many people believe, well, yeah, this is about generating some insights. Well, it is. Or it's about just predicting what's going to happen. Well, yes, it is as well. But if you're really honest to yourself, does it really matter that much that you just, especially that just you, Joe, know what's going to happen? And if you're honest, not that much, because if I just know what happens, but I'm not doing anything about this, then nothing really changes. So the only thing which really matters to your organization is that you do some action, that you do something today so that you will get to the best outcome and the best business result tomorrow. And that's exactly what we call operationalization of models. You take the model, yes, you do all the scoring, create all the predictions, but actually then there's something else which needs to happen, and this something else is what we call the operationalization. Often it's about turning those predictive insights you created into actions and then performing those actions. So that is the whole vision actually around predictive analytics if you think about this. How can analytics then help us to find the right business action? The right business action in the sense of getting to a better output or outcome tomorrow. And I would like to motivate this in general for those of you who haven't been there yet, who are new to predictive analytics, or even for the experienced people. Just I would like to help you to better understand this whole framework around predictive analytics a little bit better before we see how we can connect this to data visualization products, for example, like Qlik, to show you one particular way of operationalization. But let's spend a minute or two on the framework first. Okay, in order to do this and in order to motivate this, let's have a look at a very, very simple example. I think this is the most simple example I could think about, and it's about the weather forecast. If you know that it's going to rain tomorrow, should you bring your umbrella, yes or no? Think about this for a second. The immediate answer, well, you can't give me the answer right now, but if you think about this and you would say, like, write it down or write it in the chat or whatever, probably many people will just say, like, well, yeah, sure, it's going to rain. Sure, I bring my umbrella. I, on the other hand, say, well, it depends. And what does it depend on? Well, first of all, I know I have the weather prediction, the weather forecast is going to rain. But there might be more. Sorry, I'm getting a call at the worst point in time ever. There might be more information which is available to you. So you know it's going to rain, but maybe the weather forecast also tells you, well, it's windy, or it's going to be windy. So in that case, bringing an umbrella is not a good idea, because if you, for example, commute by walking, then actually the umbrella is going to be blown away. So that's not good. So if it's windy and rainy, so maybe you should better take the car then for your commute to work. Well, but if you take the car and it's windy and rainy, many other people will do the same, so there's more traffic, so you should plan for a longer commute. So you see that actually a very simple prediction like, should you bring your umbrella, or it's going to rain, and then the question, should you bring your umbrella, is actually leading to a half-complex decision framework already, depending on so much other information which you might have available. So that is exactly the whole point from, well, if you think about just gathering information and making your decision yourself, and then actually adding forecasts to those information, and maybe you can actually do even a little bit more with this collected information to find or optimize automatically to find the right course of business action. So, and this is really coming in like 4 different layers, and the 4 different layers really start with business intelligence, more traditional data visualization, something we will definitely see today a little bit more, and it ends with something we call prescriptive analytics. So let's go through this weather forecast here on the left, and also the churn example we already touched upon on the right. So with a pure business intelligence approach, you could look into the data from the past and say, for example, well, in the last year, it has rained on 231 days. That is really an interesting piece of information. Unfortunately, it's not going to help you at all with creating a weather forecast for the next day. So this piece of information alone is not helpful to you, or not particularly helpful at least. For the customer churn use case, you're in a similar situation actually. You could say, for example, well, we lost 5 million customers last year. That is 23% of the overall user or customer base you have. And that is good to know, but at the same time, it's also shocking, and more specifically, it's too late. You can't do anything about this because now those customers already, they moved on, they're gone. You can't keep them any longer. So the pure BI approach, as helpful as it is for so many aspects, is unfortunately not really helping you finding the right course of business action, or at least not an optimal one. So you can get a little bit better insight and build a better gut-based feeling, but you're most certainly not finding the optimal course of action to get to the best outcome in the future. Well, maybe we can add a little bit more predictive style, at least, into the mix by saying, like, well, maybe I'm not just looking at the last year, I'm looking at the previous 3 years, for example, and I know that it, for example, has rained 231 days in the last year, and 217 days in the year before, and 253 days in the year before that. Well, it's probably a pretty safe bet now to say, well, it will rain at least 200 days in the next year. So that's what I call a BI-style prediction. You basically take the aggregated information from the past, and then on this aggregated information, you find some trend curves or trend lines or some thresholds you think will be reached. Well, that's definitely better than nothing, but that's exactly what I meant before when you say, like, well, in order to turn insights from the past into predictions for the future, if all you have is this aggregated information, typically, well, it's a little bit better, but still it's kind of like a gut feeling. How do you know if it's now 200 days or 210 days? You don't really know, and especially you don't know anything about the question, is it going to rain tomorrow? So it's really difficult now to find a course of action. Same is true for the customer base. If you lost 23% in last year, 21% the year before, 25% in the year before of that, then let's say it's a safe bet to say you're going to lose at least 20% of the customers. So yeah, it's somewhat predictive, but not really. And also there's typically not a lot of predictive analytics actually involved, and that's exactly the next phase now, or the next approach. Let's say for example, you could take a predictive model now to go through all the particular days and also the information you had about those days from the past. Then you can actually take this model now to create a probability for rain for tomorrow. So now you could, for example, say tomorrow it's going to rain with a likelihood of 95%. All right, so that is really where most data scientists feel very much at home. So this is exactly what we are doing every day, finding those models so that we're actually able to create predictions for every single situation. In the churn case, we can, for example, create a prediction now which tells us you will lose John Smith tomorrow with a likelihood of with a likelihood of 92%. So this is really the norm. But if you add actually the predictions to other information and run optimization methods on top of this, that is now really what we call prescriptive analytics, because now you, for example, take other information into account and figure out, well, with the other information, I actually should go by car and plan for a longer commute. Or, for example, in the case of Mr. Smith here, in the churn case, we could figure out that I should give Mr. Smith a call, tell him about our new service improvement initiative, and also offer a 3% discount on renewal. 3%, not 10%. 3% is enough to keep John Smith. So finding the right course of action, that's really the realm of prescriptive analytics. So that is interesting, because if you think about the value really, then funnily enough, often the value of the BI-like style predictions is actually relatively small. You can't really act on this. It's really more insights, and yes, you can make some business changes based on that, and this will definitely deliver some value. But the interesting thing is that by going down to the detailed level and automatically do the right thing for every single situation, that creates even more value. So there is really kind of like an operationalization spectrum then. So, and this spectrum really is interesting because some of the elements I would not even go down that route and actually create like those millions of like smaller predictions. It's really, those are the cases which are more, well, infrequent and often are a little bit more, strategic, a little bit bigger decisions you need to make. So this is why we start on the bottom left here. This is, for example, a strategic decision like, well, should we create a new product line, and what kind of product line? Should we acquire a company? And often the best way to achieve this really, well, you definitely can use analytics in general, but also predictive analytics to figure out what's most likely going to happen. But really those are like kind of on-off decision and they take a long time, and automating them probably doesn't make a lot of sense. Even for many tactical decisions, for example, defining pricing policies or underwriting policies, doesn't make a lot of sense. But if you go further down here, so the number of decisions typically grow and the duration per decision gets shorter, like for single decisions, for example, making a specific hire, define a price for a specific product on a specific day. Those are decisions where you can now operationalize a little bit more. Scale plays an important role here because just the number of decisions grows. And then you go further up here into operational and fully automated. Examples for this would be, for example, making a cross-selling offer, approving a credit, or even stopping fraudulent transactions, which of course needs to happen extremely fast. So in our churn case, this definitely falls into this operational bucket. So if you think, for example, about a telco with 50 million customers, and they want to predict who is really loyal and who is about to churn, those are cases where you can't just have a single person have a look in many cases. But the big question here is, I'm actually skipping the next slide because we talked about this already. It's often the most valuable thing. So you can save a lot of money by operationalizing this and fully automating this. So, but the big question now really is, that is good. So we have millions of decisions. In this particular case, if you have 50 million customers and you make predictions for every customer every day, basically you end up with billions of decisions you make it. Why not just fully automating this then? So why are not taking your predictive model you have created and put this into some automation system? And RapidMiner actually can do this, as many of you might know, and just automate this and forget about this. Well, and that's exactly the reason why Joe has often some problems, sits in the basement, and is sad about this. There are so many different reasons. Sometimes people call them political or whatever they are. There's so many different reasons actually why people can't just automate this whole full process. And you want to have a human being actually in the loop. I'll give you a couple of examples. Let's say you created a model which is totally disrupting your business process, and you go to your boss and tell your boss, like, hey, look, I found this predictive model. If you would just change our business process, then we can reduce our churn rate by 10%. Of course, people are excited to hear something like that. But at the same time, well, somebody needs to make the decision that the whole business should be changed. And in order to be able to make this decision, you're not just trusting some kind of a crystal ball, because that is really what a predictive model, despite all the math and statistics, is for many people. So if the trust is not there, this decision won't be made. You're not just automating this whole thing. So you first need to understand what's going on and if this is really working, and just creating a cross-validation and accuracy estimation is just not good enough for that, because that's another thing people don't understand. So this is really, they need to see it for some time first, build some trust. Fear is another interesting aspect. So just imagine you're going to your doctor, and the doctor by now is a robot, and some pictures are taken automatically, and the decision to make a surgery is automatically triggered and done. So you're going to the doctor's office, and based on what the machine learning algorithm is saying, said like some robot is performing a surgery on you. Well, although this actual decision might be better than the decision any human being is making, I personally, and I am a data scientist, I am kind of Joe. I have some problems actually with that myself. So I can't imagine really anytime soon that I would just accept the fact that there's no human being any longer involved in life and death situation or decisions about myself. And that's kind of funny. Although I actually trust machines and algorithms a lot, I always like to have some human element in decisions like that. So this is often the case. I still believe that machine learning can support the decision-making process by, for example, pointing out the most likely course of action, or supporting, for example, doctors by looking or pointing out regions on X-rays as an example to find maybe where most likely there's some cancer. But human beings often prefer to still have a human being in the loop confirming what the machine is saying. So then there's rarity. Sure, there's like you're landing on the moon. That's not happening every single day. So probably you still want to have some human being also there in the loop, although most of those algorithms are completely flying, let's say, a spaceship alone. But just as an example, a probably better example would be thinking about you're acquiring another company. This is not happening very frequently, and it's also not just based on the question like, well, will this company we are going to acquire develop positively? Let's say you make some revenue forecast. Well, that's one thing, and a predictive model can help you there maybe, but there's so many other factors. Are the company cultures a fit? How is the market developing, et cetera, et cetera. There's so many other factors. This will be very unlikely fully automated any day soon. And then last but not least, there's just familiarity. People are not very familiar with machine learning models yet, but for example, they are very familiar with data visualization products like a Tableau or a Qlik or whatever. So, and it's interesting that this might be a very good channel for us as data scientists now for sharing the information, for sharing our models, for sharing the predictions or prescriptions with other people. And I think I will focus now most on this bottom right bucket because it can also help you actually with all the other three. So if you actually present your predictions in an environment which you're, well, comfortable with, then, or other people are comfortable with, then it's much more likely that people will accept those results. Okay, so that is really the whole framework, or the motivation really also for why should you really care about bringing together, let's say, machine learning, predictive and prescriptive models, and data visualization. Well, you can amplify your voice, you can bring this in the front of many more people. They are familiar with this, and they can be at least supported in making the right course of action then. So how cool would it be then? Well, to just do it. Deliver predictions and recommendations for actions into a known dashboard to you. And that's exactly what we are looking at next. So I'm now shifting gears a little bit and opening a couple of products. And by the way, just an invite, please feel free to ask questions at any point in time. Those are monitored and maybe from time to time thrown over to me. Let's see. But definitely at the end, we will also spend some time answering as many questions as possible. Okay, so let's have a look into Qlik first then maybe. So let's see, where do I have it? Here we go. So this is CLIXsense, well, a product which was recently released by Qlik in addition to their Qlik View product line. It's a data visualization product, a BI product many of you might be familiar with, and I created here a very simple dashboard actually around churn. So we stay on the churn use case here. We have some data for the United States, and this is now a typical result actually in a more BI-like fashion. So you took data from the past. So for example, we have aggregated information here for the different states of the United States, Montana, and so on. And we calculate some properties. For example, how much churn do we have in Montana here? 21%. So you see this on the table here on the right. Or in Delaware, 14%. Or in Colorado, which is 13%. So you have this information. Of course, you can visualize this like in this map here. We can definitely see that Montana has the highest churn rate here. We have, what's that, New Hampshire here. Well, I just moved here a couple of years ago. Don't ask me for every single state of the United States. I probably will like terribly fail. So let's not go into more details here for now. So that is a typical situation. And of course, I could now drill down here and have a look. For example, if I am a regional manager, I'm most interested in Maine and New Hampshire and Vermont and Massachusetts and Rhode Island and Connecticut. And now I'm actually almost impressed that I found all of them right away. Well, this is really your region. Let's say you're responsible for New England. So this would be your region here. You can make a selection and you can get the updated information here. Well, we have all those states here. New Hampshire actually most churn, or highest churn rate actually, followed by Massachusetts and so on. The average churn rate is 9.78%. Those are typical applications, so you know about your region now. Well, I have a too high churn rate, maybe I should do something about this. But what now? What can you do really? So, and that's exactly where now the combination of a data visualization product like Qlik and RapidMiner can kick in. So this is just the first dashboard I created here in a more BI-like sense. Let's make now the selection. So we have now selected those 6 out of the 58 states here, as you can see here at the top, and move on to this prediction tab. And in fact, I do something now right away, because the last time I did this for Montana. I have to reload now the selection or the data calculation for the selection is just made. So what's happening now in the background is I take the selection, those 6 states, the New England states, deliver this information about the selection to RapidMiner. RapidMiner takes this information, creates a model for churn for those 6 states, makes a prediction for all the cases where we are most interested in, and delivers those predicted cases back into Qlik. That's exactly what happened in the background. And additionally, we see the most important influence factors here and how do they differ for your New England state. So if I scroll down here, you can actually see now how large are the predictions for your region. And you can see, well, also in the future, New Hampshire will probably get most churn. The rest is pretty much equal compared to New Hampshire at least. So you now get the predictions for your own region, so where is going to be most churn, so where should you maybe focus on. And this is now in contrast to the dashboard. Well, in this particular case, it was New Hampshire, it was very strong in both cases, not a huge surprise, but at least you got this confirmation here as well. Well, the other states actually changed it a little bit. But then also you can see typical reasons for churn, or maybe not always reasons, but also like, okay, is there some patterns which are like sticking out here? And indeed, for your region, New England, you can see that actually this age bracket between 20 and 30 here is much more likely to churn. Actually, in fact, 2.5x, around 2.5x more likely than what you see in all the states. So in this red curves here, or the red bar charts, this is the information you have for all the states. But in your particular region, this age bracket actually is even more important. Also, the number of males are higher. So if you, for example, now want to work with your marketing team on this couple of churn campaigns, it might be a good idea to focus on this age bracket first, like male people between 20 and 30. So that is good. Now we know what's going to happen. We get some prediction about your region. You made the selection like you're used to in CLIXsense. You get the prediction delivered, and I will show you later how you actually integrate both products. You get the prediction delivered into Qlik. But can we go a step further? And of course we can, because RapidMiner is not just creating the prediction on top of the aggregated information. We can also get the prediction really who are the customers, how many customers per state. Again, most here in New Hampshire, 7 I think, followed by Massachusetts and so on. And who are the customers with the highest likelihood to churn? And this is exactly what this table here shows. Sorted by churn confidence. Those are the people you should focus on first. Those are the people who are churning most likely. Then if I scroll down a little bit, we are getting to a region where people are actually not very likely to churn, but I also created a so-called upselling model. Didn't talk a lot about this, but you probably are familiar with the concept. And this upselling model here, we created actually for all those people who are not likely to churn, and who are currently using one of our cheaper product packages, P2 and P3, we figured out who is most likely to, well, is most willing to purchase the more expensive package, P1 as well, or instead. So this is now very, very actionable insights. You know exactly who's going to churn, so you can focus on those people. You know where you have some opportunity to increase your revenues. So if I would be responsible for the New England region, I would know exactly what I need to do and can actually act on this. And this is exactly the difference between here on the dashboard side. As we all know as data scientists, like, great, I know what has happened. I would focus maybe on Montana and that's it, or whatever. Or here, I would just see, well, yeah, New Hampshire, Massachusetts here. But Massachusetts becomes actually less of a problem for whatever reason, maybe other activities we already did. So let's focus on New Hampshire here, and those are the people who are churning in New Hampshire. We can see here and can focus on them. So it's actionable sites based on the predictions of the futures. And this is really, this is of course what now RapidMiner can bring to the table, but instead of having the need to understand every single model, people can stay in their usual working environment, which in this particular example here is CLIXsense. Okay, so how are we doing this? Let's switch over to RapidMiner. I hope you can all see my screen here. This is the process I have created. A very simple one. In the beginning, I just load the raw data. Then actually I take the parameters from Qlik, and the parameters I'm taking from Qlik actually are just the states we are selecting in the beginning. We could also select the year we're using for modeling, but actually I didn't explain this, so let's skip this for now. It's smaller here. So here we have now basically a filter defined, which is using the states which are coming from Qlik. Well, some of you might not be familiar with this format, and some of you might not be very familiar with RapidMiner at all right now. So this is a so-called macro, which it can be filled from outside of the process. In fact, here you can see that I pre-filled this with all the states of the United States. So as a default, I just deliver everything basically. So I'm not filtering out anything. So that's what's happening here, but Qlik then can deliver the inputs. Well, those are the states I clicked on, and so those are the states I, as a region manager for New England, I'm most interested in, so deliver this. And then the rest is, well, kind of typical data science stuff. So if I show you the data, let me actually see if I find this right away. Well, I'll take it from here in RapidMiner, why not? I have here this churn status column, and you can see that in many cases we don't know the churn status, meaning like we don't know if those people are going to churn, yes or no. And in other cases, we actually have this information about loyal people, and somewhere we also have the churn cases here. Okay, so of course, as always, the task is to build a predictive model, taking the information we have into account and predicting those are the people we know about. We're filtering those people. And create a churn model, and then we apply this model on the people where we don't know about, and those are the predictions we have seen in the second and third dashboard. Now we do something very similar here on the upselling opportunities. So we know what packages are used, and we can try to find out, are there opportunities for people who actually show a profile which is closer to the higher valued packages, which is P1 here in the end. All right, so other information in the data, just very quickly. So we have information about how much they spent in the previous 3 years on the mobile billing and the landlines, the age, the package they are using, the gender. Well, we saw this already in the dashboard. Okay, so typical data science workflow. So what can you do next then? Well, the next step is actually that you can easily store this on RapidMiner servers. So you install a new server repository. You can do this here and create a repository and take the server here. And after you created a new server, you can save, just really, that's all you need to do. That's how our deployment works. It's pretty simple, actually. You just save the process on the server. And after you did this, let's now shift to a server. It only takes a few clicks, actually, to turn this process now into a so-called web service. Okay, let's log in here. If I can type my password correctly. All right, so all you need to do is really, you go to the process we just deployed on the server here, which is this churn and upselling process. You take this process, and you can click here on Export as Service, here on the right side. And after you did this, you get a new web service. Here we have this. And this new web service is really easy to be configured. So this is the process which is going to be executed. You can select what kind of output you want to create. You can create charts or maps or XML or JSON files, or deliver whatever can be created with RapidMiner. But in this particular case, I just go with a very simple table here. And now the last thing I can configure is, well, I have 2 macros for the year used for modeling. I call it M2, and the states I'm most interested in, that's PM1, and I bind URL query parameters to those 2 macros. What does that mean? Well, if I test this web service here now on RapidMiner server, you can see now that I can get here some URL, and for example, can say let's go with New York. And test this thing. Oh, just sorry. Now I'm only getting the information for New York, so instead of the full data set. So I'm getting now all the information, like for example, what is the prediction in cases where we knew it already, we don't need a prediction. All other cases we have the prediction, including the confidence and so on. So every single piece of information is here delivered now from this web service. Now you can take actually this URL and feed it into Qlik. So let's move over here. And how are you doing this? Well, in Qlik there is this data load editor. And I'm not really truly a Qlik expert myself, I have to admit, but I spent a couple of hours really only in learning how to use it. And I have to say, like, yeah, I managed quite fast to really set it up. All I'm doing here is, well, I define a new data set I call Churn, and I'm loading all different kinds of columns here, and I rename some of them, all different kinds of columns here from this URL we just have been specifying. And I can use those parameters here. Those are the states which are selected. As a default, I select all of them, but later you would see how we can also, or here you actually can see already how we can select specific states, or also here the year. This is the way how you can actually access the information where you clicked on in Qlik. So you use the dollar symbol and then round brackets and the variable name. In this case, it's year selected. If I scroll down a little bit, you see the same also here. I thought at least, where is it here? Where I actually do the same for both selecting the states and selecting the years. So this is the format. That's all you do. So you define the name, you define what columns you're interested in from this table which is delivered by the web service, and then it's just the URL from the web service you just can copy here from this direct link. And that's kind of it. Then you click on load data, and that's it. So it takes a while. All right. So now I upload the data, and I can now go into our into our app here in Qlik, and can work with the data as we have seen this before. So this is the overall workflow. There's only one small caveat for those of you who use both products specifically now and want to try it out. After you made this selection, you need to tell Qlik that it actually needs to reload this data. If you look up on Google for Qlik reload button, then actually you will find a nice solution how to do this out of the dashboard, which is a little bit more elegant than actually making you go back to the data load editor. Both ways would work. You can reload them through the editor. That's kind of the standard CLIXsense way, or you add this reload button here to your dashboard, which is, I find, a little bit more comfortable than going into the editor. Okay, so let's go back into the presentation, and let's recap what we just saw. So how do you amplify predictive analytics with Qlik? In general, probably with all data visualization tools, we use or make use of this deployment mechanism of RapidMiner server. So you design a process first, an analytical process in RapidMiner. Then you just save it in the RapidMiner server repository. And on the server, you go into this web interface and turn this process into web service. So that's basically one single click and return a table. Now on the Qlik side, you add this RapidMiner web service as a data source. You design a dashboard like you always would do this in Qlik or in CLIXsense. And then whenever you make a selection, you can also feed them through this mechanism into RapidMiner processes. So basically react to user selections and whatever the user is most interested in, make all kinds of processing and deliver the results then back to Qlik. And just a little side note, since we can build all kinds of processes, of course you can only, quote unquote, only use this for creating predictions, but you can of course also do all other kinds of data preparation work, especially when it's more data prep around, let's say, more advanced statistics, like for example finding and removing outliers, or well, what else, like normalizing data, all this kind of things. You can do this kind of data prep, of course, with RapidMiner, as many of you know. Actually then run those RapidMiner processes to prepare the data for Qlik as well. So we, of course, also have the whole data blending and cleansing functionality is part of RapidMiner, so you can do this. Or, since you're still a RapidMiner process with 1,500 operators in total, there are lots of operators, for example, to sending out emails, triggering other web services. So whatever you can do in a RapidMiner process, you can embed this course of action also now into Qlik through this web service integration. And in general, for those of you who are a little bit less familiar with RapidMiner, and this might be the first touch point for you, in general, this is really an important point for the whole RapidMiner platform. So we really go through all three very important, well, phases of the data science workflow, the analytical life cycle. So the first phase, or most often the first phase, is really like ingesting and, more importantly, preparing the data. So really like connecting all the dots, connecting all the data points or data sources, making sure that you blend them together in the right way, clean the data. So really there's hundreds of operators in RapidMiner for doing the data prep part. No matter where the data is coming from, no matter what the scale is, you can do the data prep in Hadoop clusters, in memory, wherever you want. The same is true for the modeling and validation phase, which is of course key to figuring out what's going to happen and finding the right course of action. So finding the right machine learning model is a central point. There's 250 models in total in RapidMiner. You can all try them out. You can also do a lot of model optimization and automation, and automate this whole process, like doing the right parameter selection, figuring out what the right features are you want to build the model on. So most of you will know this, but just for the few of you who are never have seen RapidMiner in action before, it's really very powerful there. And of course, the validation is equally important, so you know exactly how well those models will work in practice and in the future. And then the last bucket, that's really the one we focus on today most, is really the operationalization bucket. And in general, of course, you can deliver all those results into all kinds of business applications, can also automatically trigger the execution of certain actions. Just imagine, for example, instead of just visualizing the churn cases, why not just creating a campaign to those people and automatically, let's say in marketing automation software or HubSpot, you name it, and sending out this campaign. So you could, in theory, automate this whole process, but as we have discussed before, that's not always the best and most appropriate approach. So sometimes really the best approach is just to embed the predictive insights and actions into a data visualization platform like Qlik. So this is a particular example for one particular operationalization then. And then before we wrap and open this up for questions and answers, I think really you should give it a try. Also this integration with RapidMiner in general. We talked a lot about the operationalization bucket, which is definitely one of the things which also makes us very unique how many systems we can connect and how well the predictive modeling is then integrated into the usual business workflows. You know that RapidMiner really is about the self-service predictive analytics aspect. So yeah, it's code optional. You can code if you want to, but you don't have to. So you really, it's very easy. It's effortless, as we call this. We guide you with things like our wisdom of crowds, so you can actually get recommendations. What's the next best step? Very important for us. This speeds you up, finding the right model. We saw in the beginning, like, why is Joe still taking like 6 months? Well, because sometimes there is nothing in the data. But like in those 6 months, he was running through so many different data sets and tried so many different use cases. And that's only possible because we're accelerating this whole model finding process. And of course, as an open source leader here, we really embrace a lot of innovative solutions coming from ourselves, but more important actually also from our community, and embrace also other modern solutions, especially in the big data space. Yeah, I think I will kind of wrap it at this point. So it's a great platform. CLIXsense is a great platform as well. To bring together two great platforms seems to be a very, very good idea. For those of you who have CLIXsense already or QlikView, it works practically in the same way. You should definitely give it a try and move there, because this is really the key, as we discussed in the beginning, the absolute key to really get your voice heard and make sure that your models are really well recognized, and then hopefully also fully operationalized and optimize your business processes. So at this point, I would like to open it up for questions and answers. Haley.
Thanks, Ingo. So thank you for a great presentation today. You covered a lot of really great information, and we appreciate your time. So as Ingo mentioned, we'll take any questions that you might have now. If you could submit your questions through the questions panel, we'll take those questions now. So it looks like we have a question here for you, Ingo. Is this integration possible with QlikView Enterprise Server, or is it only possible with Sense?
No, it's also unmuted. Yeah. No, it's also possible with QlikView Enterprise Server, and it works practically really in the same way. In fact, the first, unfortunately, I don't have a QlikView now readily available. Otherwise, I would show it to you. The first demonstration of this we actually first created with QlikView, and it works practically in the same way. On our documentation server, docs.rapidminer.com, either it is already published or it will be published in the next couple of days, there's a complete set of documentation around QlikView and CLIXsense and how to integrate this. So it's possible with both, and it's also then well documented.
Great, thanks. I have another question here for you. This person says, I use QlikView mainly. How does one integrate QV and RapidMiner? Is there a QV connector for RapidMiner? And do you have example apps for this integration?
Unfortunately not. I don't have an app I could show you right now. Too bad. Yeah, good point. So there's a couple of multiple ways. The first thing I should also mention, also for RapidMiner we have the possibility to write the QVD files, I think is the extension, I don't know exactly, but we can actually export all kinds of data into the QlikView format right away, and from there you can load it again. That is, I'm saying, always possible, and it's a good way. Or in addition, similar to the answer before, you can also make the integration via the web service, and that looks practically the same as we saw this now for CLIXsense. No significant differences, different UI, but that's about it. But the concept stays exactly the same.
Great, thanks. We have another question. Can we get a trial software?
You're asking for CLIXsense or for RapidMiner? The answer actually is in both cases yes. So for CLIXsense, you can definitely download a version from the Qlik website. For QlikView, I think the same is true. Not 100% sure though. For RapidMiner, that might be the core of the question. Yes, there is first of all our community edition, which is freely available to you. Also without any limitation in time, and then for our commercial offer, there's a trial version for that as well.
Great. Looks like we have another question. Can RapidMiner integrate with any other applications like Tableau?
Yes, indeed. The integration with, since Tableau was used as an example, the integration with Tableau is not let's say, completely bidirectional. So we can, for example, deliver data into Tableau through the OData format as an example. We can also write to Tableau or into Tableau formats just out of RapidMiner processes. What I mean by not completely bidirectional, right now, to the best of my knowledge, we can't take, for example, user selections out of Tableau and deliver them into RapidMiner web services. Well, our web services can do this, obviously, but we just saw that here for Qlik, but there is no integration on the Tableau side for this full, what I would call like a bidirectional communication. Besides that, since Tableau was an example, there's many other data visualization products out there. Almost practically all of them by now support this kind of like a web service-based integration, and so the integration, in theory, always works in more or less the same way. But in addition to this, we also have a lot of other business applications, let's say like Salesforce. We have Salesforce connectors, Marketo, HubSpot. We have a lot of connectors really for on-premise based software, but we have even more, and in fact by now more than 500 connectors to cloud-based business applications. So I would be so bold and say you name the application and the answer is very likely going to be yes, we support that as well.
Great, thanks. Another question. Are you able to embed R and Python code with RapidMiner processes?
Of course we are. Yeah, no, that is actually a feature which is relatively frequently used because so many data science teams have R and Python coders on as part of their team. Let me just actually create a new process here. Not even sure if I actually installed it. Yeah, here, for example, I have the Python scripting installed here. So there's an extension on our marketplace. So in general, whenever you are missing something in RapidMiner, it's always a good idea to click here and get more operators. This will bring up the RapidMiner marketplace. And on our marketplace, there are additional operations which are created by RapidMiner or by third parties or community members. So the Python and R extension, here's the R one, didn't see that one, what's up here, execute R. I think that's actually, yeah, no, it's the right one. So the R and Python are both RapidMiner extensions, so we are hosting those. And really, what all you do is really you put them as part of your workflow. So let's say you have some data, you can even feed the data into the Python script here, and then you can do whatever you want to do inside of this of the script. So you can add your own homegrown data prep scripts or your most preferred model, if in case you have something in Python or R, and can then deliver, as we do here, the results at the end which are then can be fed into the RapidMiner process again. And I think this is a really important question, because sometimes you have such a special data prep step. Just as an example, there is often you can build RapidMiner process for that, but if you already have an R script or a Python script which is solving a particular problem, why not just embedding this? And I think the key point I would like to make around this is, if somebody of you spent the time to code this, wouldn't it be actually a nice idea that you can share this with so many other people, maybe even non-coders as well? That's exactly the idea. You can now create your favorite scripts, manage them in RapidMiner, can even save those predefined operators here with those scripts as a building block so that you and other people can reuse them. Again, accelerates your work, supports the collaboration as a team, and allows you really to get the best out of both worlds, out of the R and Python scripting world, as well as the non-coding world, which often makes you faster for those standard tasks, like you don't need to code whatever, how to do multiple nested cross-validation, including a feature selection, parameter optimization, etc. This is something you could actually click together with a couple of clicks in RapidMiner, but you would need multiple hundreds of lines of code to actually implement this now in Python. So it's really, I think it's all about combining the best of both worlds, and that's what I call code optional. In the beginning, you don't have to code for practically all use cases, but if you want to, you can always do it. Last quick comment on that one. Since we also have our Hadoop offer, which is pushing down computations into Hadoop clusters, we also support PySpark and Spark R. So even if you want to push down the execution of R or Python scripts into Hadoop clusters, you can use RapidMiner for actually governing or even this process. So, and that's really what we see often in practice, that people really use RapidMiner as the governing platform, also taking care about version control, scheduling, the operationalization aspect, the integration through web service and database tools, doing all the standard analytical tasks, and then somewhere in the middle is your very, very specialized R script or Python script solving a problem only you have, where you actually have to code because there's no other ways that you could solve it. And this is really a very efficient way to work, and the situation we encounter quite frequently.
Great, thanks. I have another question here. Can the integration with Qlik be used in the community version of RapidMiner?
Well, you need, there is one way at least to do this, which would be basically by writing out the file format. Is that actually part of the community edition? I think so. So that would be one version, but it's of course not that elegantly then the integration with the web service, because that's this truly bi-directional approach where you can also react directly to the user selections in Qlik. For that, you would need the RapidMiner server product in a version which is not freely available as a community product. This is a commercial offer of ours.
Great, thanks, Ingo. I have another question here. Can you do market basket analysis in RapidMiner?
Yes, you can. There's actually, again, on the marketplace, I don't think that I've installed this right now. Let me see quickly. No, I don't have this installed. There is a complete extension around this. I don't remember the name, otherwise I would look it up right now. But there's an extension on our marketplace for exactly that. We also have a couple of standard algorithms like FP growth and association rule learning as part of RapidMiner itself. So if you look for FP growth here, you already see the small shopping cart here. Those are operators which are available to you as the part of the RapidMiner core, and then there are extensions which are further optimizing those functionalities.
Thanks, Ingo. I have another question for you. How does the complexity of a model affect the actionability of the insight?
Was the question about how does the accuracy of the model affect this, or? Sorry, I just didn't get it acoustically.
Sorry, how does the complexity affect the actionability of the insight?
Well, in at least two different ways. So great question, actually. In at least two different ways. The first way it affected, very likely more complex model, if you're not doing your validation of the model right, tends to be less robust and tend to produce more overfitting. So what that means is really like that you're very good on the data you train it on, but if the data changes a little bit, and data always changes because the world changes, the model is not very robust. So I often prefer to really, even if it's not as accurate, go with a more robust model, which is maybe coming with a little bit less complexity, because I just would expect that for small data changes or smaller changes in the world, my model is not immediately outdated, because it's in both kinds of operationalization. Either if you automate the processes, you want to be sure that everything is working as expected, but also if you visualize the results to the user, if those results change too frequently, people, again, they're in this process of building trust. They wonder a little bit like, well, what's going on? Why is this model now, which created some prediction yesterday, is creating a different prediction today? That is not wrong, but it's just a result of that the world changed and the model is not very robust, so it reacts faster than to those changes, and that's not really good. Well, that's probably the biggest effect. What was the second one I had in mind? In terms of, like, of course, higher complexity also means if you actually need somebody to sign off, somebody needs to say, like, well, especially in a fully automated process, well, I trust this model, this is good. Often what I found in practice is you can prove, of course, with the right validation techniques, well, this model is going to perform well in 98% of the cases in the future, I properly cross-validated this, etc., etc. You do all your work as a data scientist, and then sooner or later somebody asks, like, yeah, but can you explain the model a little bit to me? And of course with the decision tree, or like with a depth of 3, that's easy and people can typically follow and understand. But then explain, let's say, a deep neural network, or then explain a support vector machine with, I don't know, a radial basis function as a kernel function. So, and all of a sudden things get a little bit difficult and nobody can really follow what this model is doing. So even if people get this abstract number, well, it's 98% correct, then they look into the model, they don't get it, and they really have a problem then to trust it again. This is, again, a little bit more important when it comes to the automated version of operationalization, because when the human being is still in the loop, what you can always do is, of course, you create the predictions. And often you can also create the predictions plus why this prediction is how it is. So basically show at least the influence factors which led to the prediction as it is. And by doing that, you can build enough trust in the human being. So it's really really those two effects: understandability, one thing, and then the other one is just the normal overfitting problem and missing robustness. That's why I personally, in practice, often prefer a little bit less complex model over a super accurate one coming with a higher complexity. But that's just based on my own experience.
Great, thanks, Ingo. So it looks like we're just about at the top of the hour, so I'm going to go ahead and wrap up the question and answer. If your question was not addressed on today's session, we'll have someone follow up with you with an answer to your question. So as a reminder, the recorded version of this presentation is going to be sent to all registrants within the next few business days. And RapidMiner will also be at Qlik Connections next week. We're a sponsor of Qlik Connections down in Orlando. So if you're there, make sure you stop by our booth. And thanks again for everyone for joining today's presentation, and have a great day.
Thanks. Bye.